the Science Gateways Community Institute brings you this webinar, and I'm going to tell you a little bit about it. So we are organized into 3 main areas of service. The first is support for building and running gateways, and that includes hands-on development support, which in fact our presenter today is part of that team. And then we also have consultants who can provide advice about specialized topics that are relevant to gateways, such as cybersecurity or usability, business planning, and so forth. And we also have a catalog of gateways and software, which is a place that not only can gateways post their projects or software components for others to discover, but it's a great way to look for components that you might want to use, or also gateways that do something similar to what you'd like to accomplish, and you can see how they've done that. So that's our first main area of support. Now we have an education and training collection of services and resources. This webinar series, of course, being one of them. We also have a week-long Science Gateways Bootcamp that is free to attend. It just requires a couple members of a Gateway team to come and pay for their own travel. But other than that, there's not much else they have to pay for. And it includes a week intensive introduction to topics that are relevant to building and particularly sustaining your gateway and getting it out to the audience you want to reach. Our student focus programs are mostly during the summer, but we do also offer some during the year. But I do want to bring your attention to the Coding Institute, which is a 4-week program that runs during the summer, and I believe that applications are still open for that. So if you know of students who'd like to know the basics about gateway development, that's a great opportunity for them to attend. Our annual conference is also a great place to learn more about how people do gateways and the technologies that support them. We are in the process of reviewing submissions right now, but the posters are still open. That is open to anyone who attends the conference. The conference will be at the end of September this year in San Diego. And finally, of course, our website is full of lots of resources and materials you might like. And then our third area of support is just the fact that we are dedicated to networking people and building a community. We do that in several different ways. One is our partner program and also our affiliates program. These two call attention to organizations that have complementary resources or software that you may want to tap into and use. And the affiliates program very specifically includes agreement by those affiliates to support projects that are interested in using their software. We also have a blog, and we welcome guest contributions to that blog. We post news, and we want to hear about your news and job postings as well, so send those along to us. And we have a new-ish community forum, which is a Google group that you can join, which we post some items there as they happen, but in particular, it's a great way to ask feedback from other members of the community about what you want to, problems you might be trying to solve. And of course, the annual conference is a networking opportunity. So those 3 big areas of support that SGCI offers come together. We work interactively, I guess you could say, to deliver the wide array of things that you can enjoy through our NSF-supported program. So with that, I just want to ask one last favor, which is I'm going to post this link in our chat area, and I hope that before you leave this presentation, you'll stop by that and just answer a couple of questions. They're really short. There's basically 2 questions plus 1 option to give us suggestions of other topics for the future. So with that, I'm going to hand off to our presenter today, who is Julia Looney. She's based at the Texas Advanced Computing Center, and she's also one of the consultants who works for SGCI in the extended developer support, which is essentially the hands-on development that you can take advantage of through us. She's worked on a number of projects or been working with us for a little while now. And I believe, though, as she explained to me, that the work she's doing is more coming out of her role at TAC, but the tools that she'll be sharing with you today are general to anybody who wants to do gateways or relevant to all sorts of projects. So with that, I will hand it off to you, Julia.
Awesome, thanks. Yeah, so thanks for having me. So before I begin, I'm going to paste a link in the chat for everyone to follow along. I'll be using instead of slides, I decided to use a GitHub repository. So feel free to follow along with that as I go. But I'll also be showing it on my screen, which I'm setting up right now. Okay. So can you see my screen? Okay, cool. So I have this kind of separated up into several parts of like explanation, and then after that, I'll go through some examples. So today I'm going to be showing you this really cool open source tool called Prometheus. And so essentially it allows you to create and use time series metrics for monitoring, alerting, and graphing. And I have a link here to their docs in case you want to learn that I've come to use for quite a few different things. So I'm really happy to share it with you all today. So what's great about Prometheus is that, well, for one thing, it's open source and it uses time series data, so you can kind of track how things change over time. It also has its own query language, which so and you can, they have some very nice docs on how to use that, and it kind of allows you to create some more complex analysis for these metrics, and it's pretty easy to set up as well, especially with Docker, which is what we'll be using today. And one kind of big selling point is that it comes with a dashboard that you can do graphing on, but it's also compatible with other open source graphing tools like Grafana. Grafana is kind of a much more elaborate graphing dashboard than what Prometheus gives you out of the box, but they play really nice together, so that's great. So Prometheus has kind of 4 components to it. So there's the Prometheus server itself, which is the service that will be collecting the metrics and saving it to a database. There's the jobs or applications that will be producing the metrics. There's also an alert manager that you can set up to alert when metrics reach a certain value or something like that. And then there's the data visualization, which is the graphing dashboards. So, and that's all explained here as well. But in this webinar in particular, we're just going to set up the Prometheus server to scrape an application for metrics. And it will turn that into some nice time series data. And then we'll also look a bit at the Prometheus dashboard. Okay, so moving on to part 2. So the first thing we're going to talk about are the metrics themselves and kind of what they are, how we can use them, and that sort of thing. So Prometheus allows you to create 4 different metric types. So there's a counter, which can only be increased or be set to 0. So, you know, this might be like the number of requests or something like that. And then there's a gauge, which can be incremented or decremented. So if you're trying to track like temperature or something like that, then you can just set it to what the value is at that moment in time. And then there's two more complex metrics, which are histogram and summary, and they're pretty similar, but essentially it offers 3 data points for every time that Prometheus scrapes. So you'll get a cumulative counter for the number of observations over a specified time window, the total sum of all observed values, and the count of all of the events that have been observed. And the summary is different in that it also has like quantiles and all that more advanced stuff. But for today, we're mostly going to focus on these first two here. I find that I usually only have to use these two, but I mean, yeah, obviously these could be useful too, depending on what you're doing. Okay, so I'm actually going to take a pause here. Are there any questions so far?
Sorry, no, there's no question so far.
Okay,
I had to find my mute button. Sorry.
That's okay. Okay, cool. So moving on to part 3. So in this webinar, we're going to be using Python to create metrics. I believe there are Prometheus clients for many different languages, so you could probably find one in your preferred language, but I'm a Python developer, so I'm going to use Python. So the Prometheus people have created a Python library called Prometheus client, and it's pip installable. And so once you have this, it allows you to create these Prometheus metric objects, and it helps you convert them into a format that the Prometheus server can consume. So, for example, if we want to create a counter in Python, we would import that from the library, and then we would create our counter object, and it's pretty straightforward. All you need is the metric name and the description of the metric, and this will show up in the data that Prometheus collects as well. And then if we want to increment it, we can use this inc function, and that increments it by 1, but we can also increment it by some other value. And I believe it's not just integers, it can also take floating point values. So yeah, it's this way we can increment our counter. And then for a gauge, it's pretty similar. So we're going to import that object. And so same thing, name of the metric, and then a nice description of the metric. And so for the gauge, since you can increment it or decrement it, there are a few more functions for doing that. So obviously, this behaves the same way as the counter. Decrement is just like increment, except it, decreases the value. But then what's also useful is the set function, which will just set it to an exact value that you want to give. So this is really useful, like in this example, we're making a metric for the amount of memory remaining, and so we can just set it to that exact value at every moment in time. Okay, and then histogram is pretty similar format. We import it, we give it a name and a description, and the histogram focuses on observations. So it has this observe function, and the summary is the same thing. And the difference with the summary is, one of the differences of the summary is it has quantile information, but currently the Python client doesn't include that, but I'm assuming it will eventually be added. But one other thing I wanted to touch on are labels. So labels are useful if you have kind of multiple metrics that you want, like with a similar concept. So kind of in this example, we want to see the amount of memory remaining on a server. But say we have multiple servers, we could create a label so that we just have this one, we only have to create this one metric, but we can add this additional label so that we can use it for the different servers we have. So as, for example, if we want to set the value for each one, we would do our gauge.labels. So we first specify the label that we're setting, and then we do our set function. So, and we'll see this again later in my examples. And this is also very useful for when we do the querying as well later, because we can just focus on, you know, a specific label. So the main goal of creating these metrics is we want to generate this plain text, and this is kind of an example of what it looks like here, and this is what Prometheus scrapes. So it expects it to be in this very particular format. So for each metric, it has, you know, the description, it has the type that it is, and then it has, you know, it spits out all this data for each of the metrics. And so one really cool thing about this library is that it includes this function generate latest, which generates the latest value of all of your metrics in this format that Prometheus needs to consume it. So it makes it really easy to set up a nice, you know, endpoint where Prometheus can do its thing. Okay, so I'm going to pause again. Are there any questions?
Nope, no
Okay.
questions so far.
Cool. So I'm going to move on to the next part, which is configuring Prometheus itself. So in the previous part, we talked about how to create metrics for Prometheus to consume. But now I'm going to talk about actually how to set up Prometheus, a Prometheus server that we can use to scrape these metrics. So the first thing we need is a config file. And I apologize if you hear any loud thunder in the background. There's lots of bad storms going on today here. Okay, cool. So
as long as there's not, I don't hear the thunder, but as long as there's
okay.
no power outage, we're good.
Yeah. Yeah, totally. So the most important thing to Prometheus in terms of, you know, how it works is this config file. And so what this does is it tells Prometheus where it needs to scrape. And so essentially you want to give it a location that has that plain text that it likes. So, and it's written in YAML. And so this is a kind of a very basic example. So in this situation, we're actually having Prometheus scrape itself. So Prometheus out of the box, it has an endpoint that has metrics about itself. So, you know, it has like all the basic things like uptime and or whether or not it's like how much memory is using, I don't know, all that kind of stuff. It comes with that, which is kind of cool. So right here, you know, we have the name of it. So well, actually I'll back up. So at the top here, we have a few things. We have the scrape interval, and this is how frequently Prometheus will scrape an endpoint. The default is 5 seconds, but you can set this to anything really. And then you can also have a label in case, you know, you have multiple things going on. You can know which one is which. And then we set up the actual scrape configs. And so under here, this is where you will list your jobs. And right now we only have one, which is the Prometheus one. And so it's at the very basic level, all we need to do is set a target. So we give it a name and set it a target. And I'm just, since you know, for this example, I'm just going to be running this locally. Prometheus by default runs on port 9090. So I'm just pointing it at localhost port 9090, and that will be that plain text format that Prometheus likes. And so every 5 seconds, Prometheus is going to hit this endpoint and scrape all the metrics, and then add it to its time series database. Okay, so that's the config. And then for as far as like starting up the server and deploying it, this is where we're going to use Docker. And using Docker makes it really pretty straightforward, because the wonderful people that have created this project, they made all these Docker images that you can use that has everything you need. And all you need to do is point it to the right config file. So here it's just doing a volume out for the config file. And then, I think this should be indented, sorry. After that, this I just got from the docs, and it just, you do Docker compose up, and it'll start the Prometheus server, and it'll start scraping. So I think I forgot to mention this, but this is Docker compose. And for those of you who aren't familiar with that, it's a YAML format where you can essentially do, it's equivalent to like saying Docker run, but you can kind of package all your stuff into one file, and it just makes things kind of easier to deal with. Okay, so next it's time for the actual like running examples. So again, I'm gonna pause. Are there any questions?
Julia, I do have.
Oh, go ahead, Mona.
Julia, I do have one question. You mentioned that Prometheus has a database. What is this part of the setup that you will do?
Oh, yes, that's a good question. Yeah, so one of the cool things about it is it sets up the database like for you. And that's all contained in the Docker image. So, I mean, you don't really even have to know about the database existing. It just, it's there.
Okay, thank you.
Yeah, so it's cool. And, if you are running this in an environment where you want to make sure you retain all the metrics, there's a way of having it persist. So, and there's some docs about that as well. But as far as like setting it up yourself, you don't have to do that because Prometheus does it for you, which is cool.
And if you're using it without Docker, Prometheus still has that sort of hidden for you, right? You don't have to set
I
up.
believe so. Yeah.
Okay. All right. Thank you.
Yeah.
And there are no written questions, just so you know.
Okay, cool. Okay, then let's move on to the examples. So I'm gonna go over 2 examples here. One of them is kind of what this webinar was titled, which is collecting Docker stats using Prometheus. But first, I'm just going to go over a super basic example, just so I can, kind of show the basic setup for things. So in this example, I'll explain it first before I show. I set up a very basic Flask API that has one endpoint, and that one endpoint, all it does is it produces that plain text that Prometheus uses to scrape it. And then I have a very basic Prometheus setup that's just set to scrape that Flask API. So first, I'll go through the Docker file first. So I set up this Flask API using Docker, and so the Docker file is pretty straightforward, I think. So I'm just, I'm using a Python image since it's Flask. And a lot of this, I think, is just from the docs. But essentially, we're just going to, pip install the requirements that are needed, and then copy all of our code, and then run it. So the actual Flask app is here. And so this is where we're going to use the Prometheus Python package and put it to use. So since I'm doing a Flask app, I imported that and set up some of the basic Flask stuff. Oh, there's an error here. I forgot to get rid of this. But essentially, for this basic example, I just set up a counter, just called my basic counter. And then we have our one endpoint right here at /metrics. And I set this because Prometheus will assume that when you give it a target, it will find the data it needs at /metrics. You can override this if you want to, but to keep things simple, I put it at the location that it's expecting. And all I'm doing in this one endpoint is incrementing my counter by 1. So every time this endpoint gets called, this counter will go up by 1. And so this means that every time Prometheus scrapes it, it will be doing a GET request and incrementing this counter by 1. And then this is the cool part here. So what we're returning is the Prometheus plaintext that it likes. And so we're using this generate latest. And then this is just the basic Flask to run the Flask API. Okay, so then the Docker Compose file, I'm using Docker Compose again, just to make it easier to run everything. And so all I'm doing here is I'm setting up a service for our API, which is just, I built that Docker file we saw earlier to this location and pushed it to Docker Hub. And then I'm just making sure that the ports are correct, because Flask uses port 5000. Okay, so then I set up a basic Prometheus server that will scrape our very simple counter. So in our config file here, we have the Prometheus service like before, went ahead and kept that. And then I added a new one for our new metrics endpoint. And I called it my metrics. And so I set the target to, and this can get a little confusing, but this is the IP that Docker will use when it runs the service. If you're doing this like on a production environment, this would probably be like the IP of your server or something. But that's what's happening there. This is where the Flask API will be when this is all up and running. Okay, and then so and our requirements is just the Python packages that we needed. Okay, so can you see my terminal? You can see the browser.
I can see the browser.
Okay.
And there's one question or two questions that came
sure.
in.
Yes.
One of them may be more timely than the other. Will ask, should we be able to run the basic example using Docker Compose up -D? I'm getting a permissions error that is error :pull access denied.
Oh.
So I don't know if that is something you can solve at the moment.
It could be that the permissions on my Docker file that I pushed did not give pull access. So alternatively, you could build this Docker file yourself until I fix that. Apparently I have it so that people can't pull my, maybe that's private, I don't know. Yeah, if
you can maybe figure that out after the fact.
Yeah, but if you build the Docker file yourself and then put that image name here, you should be able to run it.
Oh, okay. All right. And then hopefully that answered your question, Will. And then Mohammed asked, is it possible to access the Prometheus database outside Prometheus for later use, for example, logs analysis?
I think so, but they also have an API. And so it might be easier to just use the API to get all that stuff. And you can use that for, whatever you want.
Mm-hmm. Okay, that's good to know. Carry on.
Okay, cool. So,
but I guess you have to show your what you call it thing. Yeah.
I'm gonna see. if I can
Yeah.
share my
You probably
terminal.
want to share your whole screen or something like that, or
Oh, okay.
yeah. Yeah, I can
Is
see your
this
terminal now.
okay? Is it like big enough? Can you see?
Yeah, it's
Okay.
readable.
So the first thing I'm gonna do, actually, maybe I should show the full screen. Let me figure out how to do that. Sorry. Higher screen. So does this show both monitors? Is that
It
working?
does, but then it
Okay.
makes everything really tiny. It's
Okay.
actually probably
Okay.
better just to show the app. Uh-huh.
Okay, cool. So I'm just gonna keep it, sorry about this, everyone. I'm gonna keep this on the browser, because that's what's gonna
Yeah,
make
it makes it
make
a
a
little
difference.
larger. And I mean,
Yeah.
if you have your terminal screen, you can you can switch between showing that as what you're showing too.
Yeah, so in my terminal, I'm just going to explain what I'm doing in my terminal because it's really not a whole lot. And if people want to see, I
Okay.
can show that in a bit. But so what I'm going to do in my terminal is in this directory that we're in here on GitHub, I'm going to run Docker Compose up, and that will start our Flask API. And then in another terminal, I'm going to be in the Prometheus directory, and then I'm going to run Docker Compose up there. And so then that will start up the Prometheus server. So then, since I'm running this locally, I'm going to go to the address that it will be. And so here, this is the result of our Flask API. And so here we can see, that might be too small here, I'll zoom in. We can see our counter that we made, and it's at 2 because I refreshed once. So if I refresh again, oh, it's actually going up because Prometheus is also scraping it every 5 seconds. So we can see it's going up every time we refresh. So then if we go over here to our Prometheus server, let's see, this is the basic Prometheus dashboard. It's at, localhost 9090. So here we can type in the name of our metrics. So I think I called it like my basic counter. Okay, yeah, my basic counter. And if we click execute, we can see the current value of that counter. And so if we click execute again in like 5 seconds, it should go up again since Prometheus is hitting it every 5 seconds, and that's what triggers it to go up. And we can also see a basic graph. So here we can see it increase, kind of cool. And another kind of cool thing that I like to use for debugging in particular is, on this Prometheus dashboard, it has the status section, and if you click on targets, you can check all of the targets that Prometheus, was given, and see if they're up, or if they're not up, there's what kind of error it has. And so this is really useful, like especially if you have like a bunch of targets that you're depending on, you can see the status of them really easily. Okay, and yeah, that's kind of it for our super basic implementation. So I'm going to pause again and ask, are there any questions?
No new questions.
Okay, cool. So now let's move on to our more advanced example. So back in this examples directory, you'll see this directory here called Docker stats example. So in this example, instead of just having a basic counter that increments every time we refresh the page, we're going to instead create a gauge metric that will capture the amount of memory that each Docker container running on our server is using. And so this is done, well, I'll go through. So it's set up, the structure is exactly like the previous example where we have our Docker file, our Flask app, our Docker Compose, and our requirements, and then the Prometheus contains the config in the Docker Compose file. That's set up the same way. The thing that will be changing is the Flask app because we're doing something different there. So I'll walk through this. So here is our gauge. And so this, you might, realize this looks pretty similar to the gauge in the beginning example. But essentially what we're going to do is we're going to pull the Docker. So in case you all didn't know, because I didn't know this until somewhat recently, there's actually a Docker command where you can type Docker stats, and it will show you all of the stats for the containers that are currently running. But it saves that data in these what are called pseudo files. And so every time there's a Docker container, wherever on the host where those containers are running, it has these pseudo files. So instead of having to run the Docker stats command, you can directly access those pseudo files to get that same information. And so that's what we're going to do in this example. And so you might see this here and think, what's that? Well, this is because in the pseudo files, it's in bytes. So just so it's more human readable, I made this conversion factor. Okay, so that's kind of a little intro to what this is. So we created our gauge, and we added this label because this is going to be the name of the container. So then this way we can have a label. So this way we'll have a metric called memory usage in megabytes for each container that's running on our server here. And then because so then this part's the same here. We're still putting it to the /metrics endpoint. We're still calling it the same thing here. But then this is where it gets a little bit different. In this example, I'm using the DockerPy library, which that's what this is here. So there's a Docker Python library, and so all I'm getting here, I'm just setting up a client for that, so I can just list all of the current containers. So that's all that I'm doing here. So I'm getting all of the containers, and then I'm going to loop through all of the containers, collect the name, because we're going to use that for our label, and then we're going to get the pseudo file. We're going to open the pseudo file for that container and read the memory data that's there. So the pseudo files are always stored at this location, and these brackets represent the container ID. So it'll always be at /docker/memory/container ID, and then there's this file there called memory.usage in bytes, and that will show you the current memory usage for this container. I thought this was really cool, so I'm very pleased to share this with you all. So we're just going to open that file for each container ID that we have, and we're going to read the file, collect the value, divide it so that by the megabyte factor, so we can have it more human readable, and then we're going to update our gauge with our value here. So here we have our gauge, and then we're going to set it to this specific label, which represents the container name. And then we're going to set it to the memory value that we obtained from this pseudo file. Okay, and then it's just like before. We're going to do the generate. We're going to return a response that generates the latest, and that will return that plain text. Okay. And so one other thing that's different about this version is because the pseudo files are on the host where the Docker containers are running, we need to give access to that to the inside of the container, if that makes sense. So we're going to do we're going to mount all of those pseudo files in this location. So on the host, it's at this location, and so we're going to mount that in our container. And then we're also mounting the Docker socket and from the source to the inside the container. And this just means if we do like container list inside the container, it will give us the result of that command as if we were outside the container. I know it's a little confusing. It actually took me a while to like realize it wasn't working for a while. It took me a while to realize that was the problem. Okay, so then in our back in our Prometheus setup, this is going to be slightly different as well. So, well, pretty similar. So again, all we did was we added a new job here. This is a little redundant, but essentially we added, it's going to be the same target as before. And I believe everything else is the same. Yeah, the Docker file is the same as well. Okay, so next I'm going to show it, but before that, I'll ask, are there any questions?
No, there are no new questions.
Okay, cool. So I'm in my terminal right now. I'm just getting ready to run this. Let's see. Okay, so I'm going to do the same thing that I did before. So I'm going to, in this directory here, I'm going to run docker compose up. And then I'm going to move to this directory in a different terminal and run docker compose up. Okay, so then if we go to this location again, so this is our new Flask API. And here we can see our lovely metrics that we made. So it looks like currently there are only 2 containers running on my laptop, which are surprisingly, no, not surprisingly, the Prometheus container and this Flask API. Okay, and so then if we go back to the Prometheus dashboard, we're back here, we can query our new metric. And so here we can see it gives us 2 listings here, one for each container. So here's our container name that we grabbed. So we can also go to the graph here and see some nice, data points. I'm sure the more that we do in Prometheus, the more that will probably rise. But yeah, that's the Docker part of it, and yeah, that's pretty much all I wanted to show. But I'm happy to answer any questions as well.
Okay, so far no questions, but we have a small enough group. I think that if someone also wanted to pipe up, or you're welcome to put your questions in chat as well, and I will watch out for it. Ordinarily, I can ask an intelligent question, but in this case, I am not a programmer, so I have no intelligent questions to ask.
Oh.
But it's neat to see how these counters just sort of magically do their thing,
Yeah, it is cool. I mean, even as a developer, I think it's like really magical. So.
Now, you may have explained this, and I didn't realize that you explained this, but you mentioned early at the very beginning that Prometheus has been written for or is available for a bunch of different programming languages.
Right.
Does that mean it's also available to monitor things in containers other than Docker?
Oh, that's a good question. I wouldn't be surprised if there was, but Docker is probably definitely like the big main one. Mm-hmm. I know sometimes here at TAC we use Singularity. I've not explored the capabilities of Prometheus with Singularity. But also I would like to add, this is somewhat not relevant, but if you have an existing API, I mean, you could also just add a metrics endpoint and collect metrics on whatever you want. Essentially, like I've used Prometheus for creating a way of auto scaling one of our functions as a service APIs called Abaco. And I used Prometheus to capture, certain metrics, and then depending on what those metrics were, whether or not to auto scale or not. So you can get creative with it and use it for a lot of different cool things.
Okay. Yeah, it struck me that if it's popular and well used, that it may be usable in other kinds of ways, but I just, because I only understand the basics of containers, so I don't know how that trickles into other areas. I know that there's more than Docker as a way of containerizing, though, obviously,
Right.
and
Yeah.
Abaco as well. Yeah. So, all right. Well, no other questions have popped in, so I think you must have accomplished your goal,
Oh,
which
good.
is that people understand you. Mona said thanks for a good demo. So,
Cool. Yeah. And
yeah.
I plan on leaving this repository up indefinitely, so feel free to reference it.
Terrific. Yeah, we'll put that on our website, a link, the link that you provided, and then for Will, who asked earlier about being able to run the example, maybe you'll get a chance to just see whether
Yeah.
you can make it accessible to him.
Yeah, I'll do that.
Um,
It might be that I didn't give it the right permissions or something on Docker Hub.
Okay. Um, and presumably it's easy enough to find Prometheus for people to learn about it
Right.
and check and see whether there's other resources available for that. So,
Right. Yeah.
Will
So
said, yeah, so
I
Will
put a
said,
yeah.
oh, go ahead.
No, go ahead.
Well, so Will said, by the way, it did work for me doing Docker build and then using the generated ID in the Docker compose.yml file, like you said.
Great. Awesome. Okay. Cool. Yeah, but
Great.
yeah, if you want to learn more about Prometheus, there's a lot more to it. There's also that great alerting manager, which it can be very useful for a variety of things. But their website has a lot of really good information I've found on kind of what you can do with it.
And is there a community of people who are using it such that there's like places where people are posting about that?
Um, not that I've personally experienced, but I'm
Okay.
sure there is.
Okay.
Seems like a
Well, it
lot of
says,
these open source things do.
yeah. Yeah, because I know now, with, like with basic HTML, you can just Google something and somebody will have answered a question you have. So,
Yeah.
yeah. So, it does show that it says it has a community, but it, didn't know how extensive that is. So, well, this is
Yeah.
terrific. Yeah. So,
Cool.
well, thank you, Julia, for preparing this for us.